Welcome back friends to Analytics Explainer. Today we are going to talk about confusion matrix. Yes, it is very popular, very well known measure of accuracy when you're presenting the output of your model. You must like to present it in a confusion matrix, especially if the output is binary, 1 or 0, or it's a classification problem. So let's begin. It's very simple, and I promise you that after this video you will never ever get confused about confusion matrix. So first thing to understand about confusion matrix is it consists of two axes. People generally get confused about this. So the one axis, which I would call a y-axis because it's easy to relate to actual coordinate system, the x-axis and the y-axis. So the x-axis would be the predicted class which our model will predict. The actual class would be the y-axis which is already given. So uh, let's take the example to make it simple. Let's take an example of a credit card company who wants to give credit to their customers. So they have classified their customers in two categories, good or bad customer. They will give credit to a good customer, they will not give credit to a bad customer. And the predicted class would be good and bad as well because it's a binary classification problem. Confusion matrix could be more than two class, can be built for more than two class, but to keep it simple, let's keep it limited to two class, good or bad customer. Now first thing to know about why people get so confused about the confusion matrix is these things: true positive, false negative, and true negative. When I first came across the confusion matrix, this is the thing which I was also confused about. I did a lot of study and then come up with a very simple and very intuitive understanding of true positive, true negative, and false negative and true negative. So First, first thing which people directly first mistake they do when they try to understand or explain the confusion matrix is they don't tell you that you have to decide which class you are going to consider as a positive class. So to understand true positive, false positive, anything, first you need to know what is a positive class. So let's say in this particular example, we consider positive class as our good customer. So now we know that the positive class is a good customer. So a true positive would be predicting a customer to be good when he is actually good. So if you look at in this quadrant, in this part of the matrix, the actual class was good, which is positive class. The predicted class is good. So true stands for a correct classification and P stands for positive because it's a correct classification of a positive class. That's why it is called true positive. Now you will be easily understand what is a false positive. So the true class is positive. The actual class or the true class was positive class because we consider good as a positive class, and false stands for negative or wrong classification. Why? Because the customer was actually good, the true class was good, but we predicted, this is our prediction axis again, but we predicted them as bad. So that's why it is called false. False stands for a bad classification or a wrong classification. Positive because the actual class was positive. So this will be known as false positive. Similarly, now you can definitely tell me what is a false negative. Negative stands for the class. When good is positive, bad automatically becomes a negative class. And the prediction is wrong because actually it was bad, but our classifier predicted it as a good. So it's a wrong classification. So false stands for the wrong classification. And as the class, the actual class was negative, false negative. That's why we'll call it false negative. True negative. The actual class is negative, bad. We have predicted it as bad. That's a good classification. So we get a true and negative because the class is negative. Simple. It was so simple. Now you can understand true positive, false negative, and true negative and their meaning given a class. So you must know what is a positive class before defining these terms. And if your professor or anyone tells you this is true negative, you must ask your professor, or you must understand by yourself, if professor is calling this as true negative, it means the positive class would be this one. So that you have to develop. That took me a little time, and now I'm sure that you can easily tell what is a true negative. If anyone tells you this is true negative, you must understand that what is a positive class, why we are calling it a true negative. Now we can also associate it. So just in a normal error or a normal accuracy of model, if we have say 30 outcomes, and now that you know about true positive, false positive, true negative, and false negative, let's talk about this number. So a normal accuracy is 1 minus error. So out of 100% we subtract the error. So in this case, if we want to present a normal accuracy, not a confusion matrix accuracy, we will say we had total 30 customers. We are able to predict 20 plus 3, 23 customers perfectly, good as good, bad as bad. So out of 30, 23 customers were correctly classified to their respective classes, good as good, bad as bad. So it would be 77% accurate. We can say the model is approximately 77% accurate, because it predicts 77% of the instances, 77% of the customers accurately. We don't specify, because now here in this case, or in any case, in any binary case, there could be two types of misclassification. One is predicting good customer as bad customer, and predicting bad customer as a good customer. Now you can say, or you can argue, that both classifications, whether it's good as bad or bad as good, it's a wrong classification. So why we are treating them differently? So there is a reason behind it, because in real world business problems, always a wrong classification is not just a wrong classification, but it can have different impacts in the business. For example, let's consider the credit card company example back. We have 30 customers who wants to apply for a loan, and we already have the actual classification. So we are able to predict 20 customers who are good, means they will be going to pay back the money they are taking from us, and we don't have any problem in giving them money. So we can give this 20 people money they deserve. Now we have one bad classification as good customer classified as bad customers, and these are 5 customers. So 5 customers were actually good, means we could have given them money, and if we'll give them money, they will pay back because they are good customer, because their actual class is good. But our model says, or our machine learning model predicts that these are actually bad customers. So two things can happen here. First, the company would consider them bad and they will not give them any loan, because company will think that they are not going to repay the amount. So here we can lose. For example, if the company wants to give them $10,000, company can deny them, because that's what their model predicts. Don't give them any money. So company will lose the returns or the interest they will get on this $10,000 given to these 5 customers. Total 10,000 into 5, total $50,000 interest. So for example, if they charge 10% annual interest, they will lose 10% of $50,000, which is $5,000. Now come to this example, this one, classifying a bad customer as a good customer, which means the actual identification or actual class of this customer is bad, but our model says it's a good, and there are 2 of these customers. So what a bad customer is likely to do? A bad customer may be eligible for $10,000 of credit, and they will never pay it. So for one such classification, for example, one classification of a bad customer as a good customer can lose you $10,000. So 2 such customer will incur you a $20,000, because they are not going to pay back anything. So here you are losing $20,000. Here we saw that you are losing only $5,000, because these people will pay, but you are not giving them any money, so you are not earning their interest, so you are losing here $5,000. In this case, there were 5 customers, and on 5 customers you are losing $5,000. But in this case, just on 2 customers you are losing $20,000, which is 4 times more than this amount. So see, now both of these are wrong classifications. Good as bad and bad as good, both are wrong, but the business impact or the loss impact of this class is much higher. It's 4 times higher than this wrong classification. Even if the number of misclassifications are low, only 2, the money which company can lose is way larger than it's 4 times than these customers. That's why we need a confusion matrix to present our accuracy not only in a quantitative manner but in a qualitative manner, so we can do more research on these subjects, and it will make more sense to the manager, to your manager, or to the person you are going to do this analysis for. So this is why it is important. Now we can easily make a cost matrix from this confusion matrix. So for example, let me do some cleaning here, and let me tell you how a cost matrix does look like. So if you can see, let me just get rid of this positive class. So here is our confusion matrix. These are just numbers, so this is the sum of these two, these are the sum of these two, so we can get rid of these. So let's focus here. This is associating this confusion matrix with cost matrix to calculate an expected value and to transform this matrix in one single value to make it more explainable. If the customer is good, you predicted it as good, there is no loss, or there is no cost, so we'll put 0 as cost. If the customer is good, you put him, or your model classify him as bad customer, you will lose say $100. If your customer, you will lose $100 because we talk about it, interest, you will not earn interest on this. Let's talk about this. If a customer is bad and you are giving him a good credit, he will not repay it at all. You may assume it, you have to assume it, because that's what classification is all about. So let's say the cost associated, we saw it was 4 times, so let's say it's $500. And if you classify bad customer as bad, nothing wrong, you will not get anything. So here you will get penalties, $100 for classifying a good as a bad, and $500 for classifying a bad as a good, because you know it's more harmful. So now multiply these value to corresponding cost. So here it would be, I don't know if you can see or not, but yeah, so 20 into 0 plus 5 into 100, 5 into 100 plus 500 into 2, 2 into 500 plus 0 into 3. 0 into 3, so we can just make this to 0, so we have to just calculate this 500, 5 into 10 plus 500 into 2, which is 1000. So total expected value of multiplying this with this would come out to be $1,500. So you can say there is one expected value coming out of this whole classifications. So what you would try to do, now you'll try to reduce this false negative by adjusting some parameters in your model, because you can have more false positive, because it only costs you $100 loss, but you don't want. So one wrong classification of bad as good is equivalent to 5 wrong classification of good as bad. So you can bear more good as bad, but you cannot bear bad as good. So that's why you try to tweak the parameters in your model, and you try to minimize this number by minimizing this absolutely of. So this is a simple explanation of a confusion matrix. We discussed about the importance of the confusion matrix. We discussed about the classes which are often very misleading, true positive, true negative. So to define it, you need to define the positive class first, and you need to think about if this is a true negative, what would be the positive class, and then you can calculate expected value by multiplying your numbers with a cost matrix. So this is a simple explanation of confusion matrix. We can talk about some more parameters of confusion matrix in the next part.